Ladies and gentlemen, welcome to the pre-lab video on our next lab experiment scheduled for this course. And this lab is titled Loss on Drying. Okay, so as many people, we are somewhat lazy when it concerns writing down these things. Who wants to write loss on drying all the time? So what we do is that we have an abbreviation that we like to use for loss on drying, and that's LOD. So whenever you're in a working in a laboratory environment and someone says, hey, we need to do an LOD on this, well, the very first thing that most people's heads go to is a loss on drying method, which means that you need to take this substance, whatever that substance is, you need to heat that substance up in order to drive off some of the liquid or moisture that's there. So loss on drying is abbreviated as LOD. Now here's the problem. The problem in a laboratory is that LOD also means something else. So you really have to be clear-cut on what LOD actually stands for in the laboratory that you are working in, because LOD also stands for limit of detection. So as you can imagine, we have a lot of instrumentation that is working in a laboratory at all times. And this instrumentation, it can see stuff, folks. It has eyeballs. It can see things that come through the piece of equipment to report those numbers back to you. However, the idea here is like a game of limbo. How low can you go? So limit of detection is another different type of test that we use on equipment in a laboratory to figure out how low can we go and still have the instrument to report reliable data for us. So, two different abbreviations out there in the world, both unfortunately are LODs, and you just have to have some context behind what LOD actually stands for. Are you talking about loss on drying method, or are you talking about the limit of detection test? You have to be really clear cut, but here's the story, folks. If you're in a laboratory, typically you are doing the same types of tests all the time, and if you come into a lab and the LOD is a drying method, there's probably very few times that they will use LOD for the limit of detection test. If so, they will probably say limit of detection. They are not going to use that abbreviation and confuse you every day, all day, because they haven't really discussed what LOD means in a lab. So LOD, loss of drying, and that's what we're doing today in the lab. All right, so the concept here, folks, it's very simple. This video doesn't need to be very long. It's just to give you a little bit of background into this whole world of this fancy term that's called LOD. So what will happen is that I will take a substance, and that substance can be anything, folks, that has moisture. Things are very moist. You know, I hate that term. You probably hate that term. Who likes the word moist? All right, well, we have moist things in the lab, and those moist things have to be tested for the moisture that they carry with it. So when it concerns this substance, this is what happens. I've got this chunk of stuff, and this chunk of stuff probably has some moisture that's associated with it. Well, what we do is that we heat this substance up, and that's supposed to be a flame right there. Didn't do a very good job. And typically it's not an open flame, but that is the best way that I know how to represent heat on a drawing slide. So we heat this substance up, and what happens is that the moisture, of course, is evaporated off. Whee! There it goes, up into the air and away. And we see a loss of moisture. Well, moisture has mass. Mass is the amount of stuff that something is made up of. All right, well, if we lose mass, then we will lose weight on a balance. So this is a simple calculation here. What I'll do is that I'll get the grams of the substance before I do anything to it. This is with the moisture involved. And then if I take the gram of the substance after heating, this is going to weigh less, right? It's going to weigh less. I've driven the moisture off. That was mass. That's no longer there, so my weight should go down. If I take these two and subtract them, this will give me an idea of the grams of what we would call moisture. Okay, so here's the drawback. I keep talking about moisture, and you keep thinking about water. And folks, that's okay. That's a large component of that number. It is water. But you need to understand that there's other things in a substance that can be driven off by heating it up. These are very volatile substances. They could be organic solvents that kind of come off at a really low temperature. So not only are you driving off water, which is probably what we're interested in, but you're also going to be driving off all of these other related substances that have boiling points that are lower than 100 degrees. Now, we hope that those are not going to be present, but this does complicate the loss on drying method for us a little bit, because what if we can't do that? What if we do want those behind? What if we have to do something else to those particular types of compounds? That's a whole different story, and we'll talk about that on a completely different day, not here. So when I say moisture, your mind is going to water, and that is the majority of the mass that we are talking about. But again, keep in mind, there are other substances that will be driven off other than water because their boiling points are lower than 100 degrees. And that's the temperature that water will be driven off. Okay, so another thing that I need to mention here, this flame that we use to heat, we don't really use a flame. Okay, so what we will do is we will put this substance into an oven. So these samples that you will be measuring today will be weighed, and then you will place them in an oven, and you will allow the oven to heat. Think of it as the oven at home in your kitchen. You're baking a cake for us today. Okay, so doesn't get more complicated than that. All right, well, here's the problem. The oven, we can set different temperatures. So if we set the oven at 80 degrees, folks, water's never going to be driven off. Water has a boiling point of 100 degrees. So 80 degrees is not going to work. If I set it at 90 degrees, that's not going to work. If I set it at 100 degrees, well, I'm at the boiling point of water. That's okay. But I don't want it at 100 because there's some fluctuation in that temperature. So we always go a little bit over 100 in order to drive off the water. And what you'll see today in the experiment is probably 105 to 110 degrees. So when you go into the lab today, those ovens will be set at 105 to 110. And they're set at 105 to 110 for a reason, and that's because this is the point that water is driven off, and if there's any other thing associated with that substance, well, all of those things are going to stay behind if their boiling points are not greater than 110 degrees. Again, the problem is that I'm getting rid of water, but I'm also getting rid of all of the other volatiles that come along with it as well. So there's a couple of ways to do this. One is with an oven like you're going to be doing today. However, the other one is write me a check for $4,000 and we'll let you use a moisture analyzer. And that's what you're seeing here on the screen. So this moisture analyzer is basically like an oven and a balance at the same time. And you can imagine why it's made this way. Because we are recording masses. There's a balance. And we're recording temperatures. There's the oven. Okay? Get my drift? And this is a combo unit. So literally, I'll just have to weigh out a substance, go over to the scale, the balance, and then get a mass, close the lid, heat the substance up, and then come back after a certain point in time and get the mass all over again. So this is a nice combination unit. It's a little bit pricey. We only do loss of drying a couple of times, folks. That's it. So there's better ways to spend $4,000 of our money on other equipment, on methods that we use more often. But this is a possibility depending on the lab, depending on the substances that you work with on a daily basis. The other thing I would like to say is that there is something in a laboratory called a Karl Fischer titration. And a Karl Fischer titration measures the percentage of water. Now, keep in mind, this is strictly water. So this makes this method a little bit better. I mean, if you're doing loss of drying and you really do want water only, and you don't want to worry about any low evaporative volatile solvent, then a Karl Fischer titration will kind of provide you the same number. But this is specific to the percent of water only. Again, we're not doing that today. We can talk about this on a different day, but once more, this is an idea that there's more than one way to do something. Right? There's more than one way to solve an answer to a math problem, and there's more than one way to do a test in a lab. It really just depends on what you have at your disposal that you can use. So today, what you'll be doing is that you will be taking multiple samples, probably 4 or 5 samples, and you will be getting masses of each one of these. It's very important that you obtain the masses, and it's very important that you label the weigh boats that you use, because the ovens will be shared by everyone in the class. So you want to make sure that it is what it is, and that if someone goes in and switches those boats on you, you'll know your location and your label, so that way you know exactly what the substance identification is when you remove it from the oven after the heating period. Okay? So we're going to put these into the oven. We'll let them sit into the oven for a certain amount of time, and then we will remove those from the oven and we will let them cool. A couple of things you need to be warned with. Number 1, you want to make sure that you use an aluminum weigh boat. Okay, so in the first lab, you probably used plastic weigh boats. Folks, use a little bit of common sense. You can't put plastic in the oven at 100 degrees. What's going to happen? Those weigh boats are going to melt, and they're going to get all over the ovens, and then people will be very, very angry at you because you have just ruined the oven for everybody else. So you cannot use plastic weigh boats in an oven that's heated. We have to use something that can withstand the heat, and this is the aluminum's purpose. So aluminum weigh boats are very important. Not only that, but you can write on the bottoms of these weigh boats with something like a Sharpie, and it's going to be able to be labeled without a problem. So label them, get your aluminum weigh boats, measure your substances out in them, put them into the oven, and folks, that's really all there is to the lab. That's how complicated it is, right? And I just got paid to do this. Yeah, that's kind of the laboratory sciences. That's all that you really have to do for the most part in some of these tests. So aluminum weigh boats go into the oven, you'll weigh them, you'll label them, you'll heat them, you'll remove them. When you remove them, folks, you want to make sure that you put them into a desiccator. All right, so what is a desiccator? A desiccator is this big, large, heavy piece of glass with a lid, and there's a chamber that's down here kind of at the bottom, and there's a lot of crystals that are down in the bottom of this desiccator as well. The purpose of the desiccator, folks, LOD is measuring moisture mainly, right? Okay, so if I take these hot weigh boats out, like hot plate, it's hot weigh boats. If I take these hot weigh boats out of the oven and I place them on the countertop, these hot objects have a tendency to gain moisture from the environment. So why on earth would I go through all of this trouble only to ruin my data at the very end because it is absorbing moisture from the environment? I don't want that to happen. So I'm going to take these weigh boats out of the oven and I put them into a desiccator and I put a lid on them. The purpose of the desiccator, there's crystals that are down here in the bottom. And these crystals will absorb moisture that happens inside of the desiccator chamber. Okay, so what that means is that your objects go inside of the desiccator, you put the lid on, and if there's any moisture in the environment, in the surroundings, those crystals will absorb that. So that way your sample doesn't reabsorb any moisture that you have driven off. You let them cool. When you let them cool down fully, then you can safely remove the weigh boats, put them back onto the balance, and get your final weight. And of course, weight and mass are different, but we use weight and mass interchangeably as a term in a laboratory. We shouldn't be doing it, but we do. That's just the way it is. Okay, when you use the desiccator, here's the common problem that people try to do. They grab the lid and they try to lift it straight up. No, no, no. You cannot lift desiccator lids straight up off the ring. What you have to do is you have to slide the desiccator lid to the left or to the right. The lid is seamed with vacuum grease. Very sticky substance. You don't want to get it on your fingers. If you do, it's going to be gunky and it's going to be very hard to get that off of there. You'll be sticky for hours. But the reason is we have to seal it off from the outside. So that's why the grease is there. If you try to lift the lid straight up, you'll end up breaking the lid. And folks, these things are hundreds of dollars a piece. Hundreds, with an S, of dollars a piece. So don't go break our lids, okay? The only thing that you have to remember is slide the lid to the left or to the right, and you'll be perfectly okay. You will handle the desiccator the right way as long as you remember that. Okay, so that's all there is to it, folks. That's it of the loss on drying method. That's all that I have to talk about. I've shown you a moisture analyzer, very, very pricey, $4,500 or up to get a really, really good one. And we put these products into an aluminum weigh boat because they have to be heated. We get the mass before, we get the mass after. This gives me the gram of moisture, that I'm going to say water, but it's moisture from the sample, and we divide that by the weight of the sample in order to get the percentage. All right, so the laboratory directions will give you that calculation. It will spell out that equation that you need to use. As long as you can plug your numbers in the right way, I think that you'll be able to solve that equation without a problem. Okay, so folks, there it is. There's the test. That's loss on drying. The question that I always get is why and how. Okay, so pharmaceutical world, if you were in the pharma laboratory environment, typically these are going to be your pills or your products that this company is manufacturing. So very often they would like to report some type of moisture analysis on it, and LOD could be found for those starting materials in order to make the pills, or at the end result, when they get these pills or when they get these products, they will obtain moisture content of those as well before they start to package them up. So pharma, as you can imagine, uses LOD. The problem is that they also talk about limit of detection as well. So that's a little bit of a confusing thing in a pharma environment. Food, all of the products that you'll be using today are probably food related. This is another test that food companies often will use, and the reason is because moisture, just like in pharma, moisture can set up bacteria growth. It can start to decompose these products. So food will also often use LODs as well, and these could be anything from flours to cereals. When I say food, I'm also talking about the pet industry. So pet food can undergo an LOD as well. So any kind of hard, dry material that needs to stay dry, I mean, again, think of flours and those types of products. They have to undergo an LOD. Another moisture kind of area that a lot of people pay attention to are the cosmetics world. So cosmetics can often go through a series of LOD tests based on their products. So we do not want moisture in those products either, and it's really for the same reason. A lot of bacteria growth can begin to happen. It can start to decompose your product, and by the time the consumer buys the product from the shelf and they bring it home, that product could be ruined if you're not careful. Another LOD is environmental. All right, so as you can tell, environmental will often deal with water and soil and air quality. So if we bring in a soil sample into a laboratory, and let's say that we are a grower and I'm growing some type of plant, and I dig up my dirt and I bring it into a lab somewhere and I say, could you tell me how much water my dirt's getting based on the different depths as I go down and down and down? Well, an environmental company could do that for a client if that's what you want it to happen. But there's many different reasons to do an LOD. Again, moisture, and that moisture is strongly tied to an environmental company. So we are seeing LOD scattered throughout many different purposes, and that is why I call this a general purpose lab experiment. There's so many different industries that will use this test, and now, after today, you will know how to do it. So what does that mean to you? Folks, you need to start building a resume. That's what that means. And now on a resume, after today, you can say that you have general knowledge in loss on drying and put in parentheses LOD. That's all. Look, you already have learned something in the class. You already have a resume builder, and we will keep adding these topics on and these methods on to make you sound really, really good when you graduate from the program and you go out and find a job. Or when you transfer, you can submit a resume to a university and say, look at all the stuff that I've done, right? No one's stopping you from doing that. So it's applicable in any type of purpose. So good luck in the lab today. It will be kind of boring because you're just weighing stuff out and waiting for it to dry. But folks, again, it's an easy method. And if you were working for an employer, just think, you just got paid to do this test. How easy can it be?